So let's begin. Today's lecture is, as always, uh, very important because this is the second phase. Its second phase will consist of two chapters. This chapter that we are starting today and the next chapter, inshallah. That is the second phase. And if you remember, we had three phases of our database design. The first one is conceptual design, second one is logical design, and third one is physical design. In conceptual design, we identify the data items for which we are going to make our database, the data that will be stored into database. How do we identify data items? We identify our entities and we identify their attributes. Then we identify the relationship between entities, and if there are some other conditions, we model them. So our conceptual design, we model our data items, relations, and other conditions. How do we do that? How do we model our data? Or in other words, what is the output of our conceptual design? It's a conceptual model or conceptual schema. How do we make conceptual model, conceptual schema? There are some ways, but we are following one of them, which is our ER model or ER diagram. That is entity relationship model or entity relationship diagram. In short, we call it ERD, entity relationship diagram. Alhamdulillah, we have covered the last chapter. That was chapter number 3 in our last two classes. We saw how to identify entities, how to identify relationship. We did some practice as well today. So today we are going to start our second phase. What is our second phase? Logical design. Okay. How to make a logical design? We are going to start with it. First of all, we are going to see some of the major concepts of logical design in our this chapter. This is our chapter number 5. Actually, the sequence number is 4. In this chapter, we will see the major concepts of our logical design, and inshallah in next chapter we will convert our conceptual design to our logical design, conceptual schema to our logical schema, the same thing. As you know, we saw that for each of these there are usually more than one terminologies which are used, and we have seen that several times. We repeated it in our last class, in our last lecture. The concept, design, schema, and model. These are three terminologies which are used for the same concept. If we are speaking technically a little, it can be a little bit different, but mainly these reflect the same thing: schema, model, or design. Okay, so let's begin our first step, which covers the major terminologies of our logical design. Basically, we will make logical design inshallah in next chapter, but in this chapter we are going to understand the major concepts and other things which are involved in our logical. This chapter is about relational data model and relational database constraints. Okay, let's first of all try to understand the terminologies in the title of the chapter. The first terminology is data model. Our data model, in our data model, that is the first phase of our database design. We also call it conceptual design. We identify data items that we need to store into database. So how do we identify data items? Two steps. In the first step, the data analyst or database analyst visits the company, organization. He talks to the management, the users of the systems, and all the other employees. He looks at the forms and the reports, and from there he writes all the data requirements. Then for those data requirements, we make an ERD, or another name of ERD is conceptual design or data model. You call it conceptual database design. Actually, as I told you before, it is not a database design, it is actually data modeling, conceptual data modeling, the first step that we did in our last chapter. Okay, so data model, it's a model that represents our data requirements. It identifies the entities or the things or the objects for which we need to store data into our database. Next terminology is relational. Our data model is relational. What do we mean by relational? Relational means one data item, it has some associations with other data items. The data items are not isolated. Of course, they affect each other. Of course, they relate to each other. So that is why we connect data items with each other. And I showed you also that for each of data item, we will make a table, maybe more than one table for each data item. At least one table will be there. And then we will relate the tables with each other. We will show the connection. We will make the connections of the table. So a data model in which data items are related to each other, though that is called relational data model. For example, first I give you a wrong example, and then I will give you a correct example. In a wrong example, just consider that there is a house. We need to store a data of the house and data of the car and data of the road. Are these items related to each other? Apparently, they are not related to each other. House is separate, car is separate, and road is separate. Now, that was an example in which the data items were not related to each other. Let's consider a second example in which there is a person, maybe a student or an employee, then he has his dependents, then he has his car, and then he has his home. Now we can relate data items with each other. At least we can relate employee with the car, we can relate employee with the dependents, we can relate employee with the house. So the data items in the data model in which the data items are related to each other, they have some connections. That data model is called relational data model. And this is our case of this chapter. Since our data items are related to each other, so our data model is relational data model, and the database that we will make from our relational data model will be called relational database. So our database will also be relational, yani the data items that we will store into our database. For each data item we will make a table, then we will relate the tables to each other, and the tables will be called relational tables or relational, and there is another name of the table, that is relation. So they are related with each other. Third thing is constraint, conditions. When we make database, we need to ensure some of the conditions for our data, and we will see what different conditions are there that we can use and we should use. So let's begin. First of all, the very first thing that we need to know about our relational model is table. We have, alhamdulillah, already seen that in our previous chapters as well as in our lab also. This picture I have taken from our lab. We store our data into our tables. Another name of the table is relations. They call it sometimes relations because here we see attributes. This is the table name, employee, EMP, and we have the attributes, empno, that is employee number, name, salary. These are, you can call them column heads, you can call them fields, or you can also call them attributes. Three names for the same thing. I'm repeating this thing from our lab just to refresh you. Then we have rows, and this is one row, first row, second row, and third row. Other names of rows are records or tuples. Just to see if you see here in this diagram, I hope you can see the mouse pointer. The diagram at the bottom left, you have here columns or attributes or fields, and you have here tuples, and in this table you have three tuples, and you have 1, 2, 3, 4, 5 columns or 5 attributes. Together this is called a table. Another name of the table is relation. So you should remember all these terminologies because mostly we will be using them interchangeably. This is the first concept of our relation or tables, and then fields or columns or attributes, rows, records, or tuples. Usually for your ease at the start we will use columns and rows, and then later on we will say attributes and records also. Another terminology that you see here in this slide, that is normalized relation or the normalized tables. Normalization we will cover inshallah at the end of this course in the last few lectures, so please hold on for the normalization there. Normalization means actually we remove any of the anomalies or any of the imperfection. We want to make our database perfect. So initially when you will be making tables, you in your initial design, the tables, they will have some anomalies or imperfections. So later on I will teach you inshallah how to find out what are the imperfections or anomalies. When we will remove them, then our tables will be called normalized tables. This inshallah I just briefly told you here. Later you will see all the concepts, major concepts to be covered in this course about normalization, and inshallah with the help of the practice. Okay, another example of relation or table. The name of the relation in this slide is student. The attributes of the students are name, social security number, home telephone number, address, office phone number, age, and GPA. And horizontally you see different rows or tuples. So this is the first row or first record. This is the second row or the second record. Similarly, third row, third record, fourth row, fifth row. Some more terminology about our relations or the tables. The first is called degree. Degree is basically the number of attributes in the relation. This is the relation student. How many attributes are here? You will count them. 1, 2, the first is student number, last name, first name, initial, date of birth, and GPA. Count them. How many are those? 1, 2, 3, 4, 5, 6. So there are 6 attributes in this table. We will call that the degree of this table or degree of this relation is 6. Second concept is cardinality. Cardinality means how many rows are here, how many records have you saved, how many tuples. Let's count the rows. 1, 2, 3, 4, 5, 6 rows. So degree of this table is 6. Then is domain. What do we mean by domain? Domain means set of possible values. If I say age, what is set of possible values? Set of possible values, if I call in years, it can be from 1 and it can be maybe 100 or 200, something like that. But it will not be more than 200, maybe even less than that. So we can say the set of possible values for age is 1 to 200. If I enter nowadays, I'm talking about this age, if I enter age to be 500 years, so probably it's not right. There is a person whose age is 500 in this age, this time, probably it's not the true value. And if I say GPA is 10.5, let's talk about domain of GPA. What is the set of possible values of GPA? 0 to 4, I think, or 0 to 5. For someone who is in the college, so he is more than 2.4. So less than 2.4, there is a possibility, but then the students will not stay anymore in the college. So the possible values of GPA, we can say that it's from 0 to 5, let's say, if maximum is 5. I don't remember, here we have the system of 4 or 5. Similarly, for names, last name or first name, these should be letters only. We should not allow 1, 2, 3, 4, 5. If somebody say my name is 1, 2, 3, 4, 5. It is not possible to have a name like 1, 2, 3, 4, 5. So we will say the domain of the names, last name or the first name, these are all characters, and we should tell them, okay, how much characters we should set a limit for entering the number of characters. All right, then let's proceed. This table, this picture shows you two tables. The first table is branch, second table is staff, and then we have the columns here: branch number, street, city, postal code. In second table, we have column staff number, first name, last name, position, sex, date of birth, salary, and branch number. You see that the branch number, it is present in both of the tables. So in one of the tables, where it is primary key, here it is primary key. You will learn, inshallah, by and by. Primary key, we already discussed it in our last chapter. So in one table, it is primary key, same attribute, same column. If we have it in another table, where is it not primary key, then it is called a foreign key. So in branch table, branch number, it's primary key here, and in other table, it is foreign key. Okay. So first of all, we want to calculate the degree and the cardinality of our first table, branch. What is degree of branch? What do we meant by degree? Degree is the number of attributes or number of columns. How many attributes do we have? How many columns do we have here in the first table? 4. Okay, mashallah. Everyone should reply. If you are here, you should reply. You should not look at others, what others are doing. Everybody has his or his own understanding. So you should develop your own understanding. So number of attributes or number of columns are 4. So our degree is 4. Next is cardinality. Cardinality means number of rows or number of records. How many rows or records are here in this table? Yes, mashallah, 5. So it means cardinality is 5. What about this table? Second table, what is the degree of second table? 8. Yeah. Why is it 8? Because we have 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. Degree is 8. And how many rows are here? 6, mashallah. Excellent. So it means our cardinality is 6. If I give you this question in exam or something like that, and I ask you to find degree and the cardinality of the relation, will you be able to do that, inshallah? Inshallah, bravo, excellent. Okay, this table shows you some terminologies for some concepts. We are using a relation or the table. These are means the same thing. Another name of the same thing, any relation or the table, is file. We hardly use this file ever. Second is tuple or row or record, same thing. Attribute, column or field, same thing. We already saw these things. The new things are relation and the table. Okay, when we are creating table, we are designing tables in our for our database. There are some properties of the tables or some properties of the relation. We are going to see those properties here. The very first property of the table is that each tuple or each row should be distinct. Distinct means different. Each tuple or each row should be distinct. Distinct means different, different from others. Row means all 3 values. If you see this picture, we can see that some of the rows are repeated. How many attributes are there in each row? 1, 2, 3, 4 attributes. So it is possible that 3 are same, the 4th should be different. That is possible. But all 4 should not be same. Okay, let's see. Let's ignore the first one because it's the ID. So ignore the first one. Let's talk about the remaining 3. See here, these 2 rows are, ignoring the first one, these two rows are same. It should not be there. It should not happen. Similarly, here once again you see these two rows are same. It should not happen in our relations. We will design our relations in a way that it does not allow duplicate tuples. Okay, it does not allow duplicate tuples. This is what we will ensure, inshallah. Similarly, here repetition or duplication. Once again we see duplication here. Second property of the table or relation, if you change the order of tuples, this does not matter. Let me make it full screen and then I'll come back. See here, if this record or this row, it comes at number 1 or number 2 or number 3 or number 4, doesn't matter. It does not change anything. The fourth record, it comes at the first, or second goes to 5, fifth comes to third goes to fourth. If you change the order of the rows or tuples, doesn't matter. It does not have any significance. Second, order of the columns does not have any significance. Here the first column is buyer, second is department. Here department is first and buyer is second. This does not matter. You change the position of column, doesn't matter. Okay, domain, as we already saw the concept of the domain. Here are some very interesting examples for our possible domains of some examples here. The first example is, let's talk about city. So for city, we will say that the domain is characters, because none of the city, at least I do not know any city where there are alphabets in the name of the city. So we will say that the city, it consists of characters, and maximum size we are allowing here is 15 characters only. Similarly, postcode, we can see that we can say it consists of characters, and the maximum postcode size we are allowing 8, so the user cannot enter more than 8 characters. Possible values of sex, we are allowing 2 possible values, male or female, and the size is 1, yani we are accepting only 1 character, M for male and F for female. Salary, for salary we will say the possible range is, let's say 1,000, or in this example they say that the minimum salary is 6,000 and maximum salary is 40,000. So the domain of salary, yani the possible values of salary, they start from 6,000 and they end at 40,000. So the range is 6,000 to 40,000. Okay. Then it's time to repeat our concepts of our keys that we discussed in our last class. We saw the concept of super key. What do we mean by super key? Super key is any attribute that can uniquely identify a tuple or a record in a relation. If we have a table, in that table we must have one attribute which does not repeat. For example, employee ID. For all the employees, employee ID is different. So from each employee ID, we can uniquely identify each record in the table. Similarly, with the social security number, if I say social security number 60, let's say, so I can uniquely go to the record where social security number is 60. So social security number can uniquely identify each record in the table. Similarly, I can make a combination of employee ID with the name and employee ID with the name and department ID. These are all keys, or the combination of keys that can uniquely identify each record in the relation of the table. Then we saw the concept of candidate key. I'm repeating it for you once again. The minimal super keys are called candidate keys. Here, how many attributes are here? 2. How many are here? 3. And here 1, also here 1. So the minimal are 1 and 1. So these two keys, SSN and employee ID, these are our candidate keys. Out of the candidate keys, we should select one of them as primary key. We should select any one of them. This is your choice. You can select whatever you like. You should select it for one of them as primary key. Let's say in our example we had two keys, SSN and employee ID, as candidate keys. You selected SSN as primary key. The other one which is remaining, that is our employee ID, that will be called our alternate key. Okay, then is the concept of foreign key. As I told you that one key in one table, there is one primary key. If you have the same column in another table, we will link it together. For example, let me see if I have a picture, I can show that to you. Yeah, this picture. We have two tables and a column here in this table branch. This column, branch number, we declare it as a primary key. And we see that the same column also occurs in another table, staff. If a primary key column also, from one table, it also occurs, it is also present in another table, then we link these two columns together. Because it's branch number, we should link it together so that the values are same. That's the purpose of linking. And when we link it together, the primary key in one table will be called foreign key in another table. Just like I gave you example in last class that I am, for example, the national in Pakistan. So let's consider this is the table of Pakistan, and here is my ID. So it's my primary ID in Pakistan. When I come to Saudi Arabia, this is the table of Saudi Arabia, then here the same person, me, Dr. Farrukh, will be a foreigner. Same person here is primary and same person here is foreigner. Okay, so my ID in Pakistan, I must be connected with my ID here in Saudi Arabia, and this ID here is the foreign key, and this is my you can call here, for example. Yeah, here I have a different number, a comma. Let's not go into that depth. Okay, we saw three keys: primary key, alternate key, and foreign keys. Also super key and candidate keys. Okay, once again we have more examples for our understanding. We have two tables here. The top table is branch table, the lower table is staff table, and you see the columns in branch table are branch number, street, city, state, zip code, and manager staff number. In second table, which is the staff table, we have columns or attributes: staff number, name, position, salary, branch number. And you see here in branch table, we declared branch number as primary key. The same branch number occurs also is other table, staff. So we will link this branch number with this branch number. Here in the parent table, it is primary key. So in this table, this will be referenced as foreign key. Look at another example. We have staff number here, and we also have a staff number here. Okay, so this is, you will say this is manager staff number, but actually this is staff number. This is ID of the staff who is the manager. So this is staff ID actually, and staff ID also here, same column. The column reference or the text here doesn't matter, but we understand that this is staff number. In this table, we said that this is primary key, and when it is available in another table, we will call it a foreign key. So here it will be a foreign key, and in its parent table it will be primary key. Okay, after the keys, we are going to see some more conditions, some more constraints that we should implement on our relational model. These constraints are called integrity constraints. What do we mean by integrity constraint? A constraint means it's a condition, it's a rule, it's a restriction. There are other al-quyud or taqyid that we need to implement on our relational model. In English, we call it integrity constraints. These conditions or these quyud ensure that our tables or our relations are perfectly normal. They are not having any problems. They have perfect data sets. They have good data which is free from problems. Okay, to ensure that everything goes fine, we need to implement some of the constraints. Okay, the very first constraint, it is called no duplicate values. If at some column we want to make sure that there are no duplicate values, we declare that column either no duplicate and we write it with ND, or we call it unique. It means it will not allow any duplicate values. For example, let's see here. This is the table. In this table, name of the table or the relation is student, and this is the table student, and these are the attributes: roll number, name, class, phone number, registration number. And we find that this is the roll number, it's a unique, and we declared it as a primary key. So this is the primary key. Phone number, will this column ever be repeated? Can two persons have the same phone number? In this age, no. In the past, yes. In this age, we want everybody to have a different phone number. So we know that these numbers will never be repeated, so we declare it a unique key. Similarly, the registration number of any two students will never be the same. Registration number of any two students never ever is same. So we declare it a unique key so that when we are inserting data, automatically database will check that it should be unique. So when I enter a new record for the same registration number, it will check it. Does this exist before? If it exists before, it will give me an error. So unique key means I cannot repeat that data. Another example, employee ID is never repeated. Similarly, the contact number, the phone number is never repeated. So we declare, we set it unique. Contact number, we set it unique. Employee ID, we set it unique. Okay, very good and very lovely slide which we are going to see now. I please all of you ensure that you understand it and you try to answer this question here. The good news is Oracle provides a live practice working database access on their website. So it will be, we will go to their website and we will use SQL in Oracle, just like you would have been doing it on your system. So you use it on your system if you have installed it, or you can use it on Oracle website. Okay, Ibrahim, also that's good, at least you have installed it. Maybe there are some dependencies which are not covered, so that's why you are having some error. Don't worry, inshallah, it will be all fine. Now we will be running it directly from Oracle website, and no need to install it anymore. But actually I wanted you to learn it for your project and also for your own hands-on experience. Okay, let's guys, let's get back to our lecture. We are studying unique key constraint. Yani unique key means no duplicate values. Now look at this slide. This is the table. Its table name is departments, and first column is department ID, then department name, then location. I want to insert a new value. Okay, here I mentioned department name as unique key. What does this mean? It means you cannot enter repeated value, that you cannot enter the same value again. Okay, so this is unique key. D name, department name is unique key. Now I want to enter a new record where department ID is 50 and department name is marketing and the location is 1700. Should I be allowed to enter this new record? I be allowed to enter a new record with 50 marketing and 1700? My department name is unique. What are the department names there? Administration, marketing, purchasing, human resources. I want to enter a new department with the name marketing. This is unique. So if I enter marketing here once again, it will be duplicated. Yes, there is already a marketing department. So if I enter a new record with the name marketing, it will be a violation of unique key constraint. So I should not be allowed. I should not be allowed. When I try to enter this record into database should stop me. It should say to me, sorry doctor, you are not allowed to enter this record because it will violate our unique key constraint. Okay, second example. I want to enter a new record where the values are 60 null and 2400. Should I be allowed to enter this new record? If I enter a value which is null, yani absent, I leave it blank, but the new values are 60 and 2400, I should be allowed. Null is not repeated. Null means nothing, absence. So absence is nothing similar to something else. Absence is absence. Okay, so it means null is allowed in unique key. However, the duplicate values are not allowed. Second constraint, here we saw unique key constraint. We are going to see the second constraint, which is not null value. Yani we cannot leave something absent. If I declare some column as not null, you cannot leave it absent. You cannot leave it blank. It must be some value. So not null means value is mandatory. When you enter your data at some websites, some of the attributes you see star in front of those attributes, in front of those fields, star. So if you leave that item vacant or absent, or you do not fill it in, you get an error because these are mandatory items. So if you want to make something compulsory or mandatory, or you want to ensure that this value cannot be blank, you should say it not null. How do you say not null? NN. You mention it, NN. If you mention something as NN, it will be not null and you cannot leave that in your database. Okay, look at here. This table is employee, emp table, and it has attributes: employee number, employee name, job, manager, hire date, salary, commission, and department number. And we mentioned this column employee name as not null. So it means you cannot leave it vacant. You cannot leave it blank. It is not possible that you insert a new record and this value, this employee name is absent. We do not allow this. Second, however, for our commission, we do not say that it is not null. We do not say anything about this. So it means null value is accepted. You see here in the first record, there is no value in the first record. The commission is absent. It is null because we didn't put any condition. If we put a constraint, not null, this value must be there. If we do not put any condition, by default, null is allowed. Okay, guys, it's time for you to win stars. So look at this table and find the integrity constraint in the following table. Where are their integrity constraints? This column, employee number, I say it is not no duplicates and not null. This is no duplicate. This is not null. I don't say anything about here and here. So it means duplicates are accepted, null are accepted. Here, duplicate are accepted, null are accepted. Is there any violation of integrity constraint? Can you tell me where are the integrity constraints violations? Yes, it is not null, but fourth value is absent. Okay, fourth value should be here. Fourth value is absent. So this is one violation. Any other violation? No duplicates. Do you say duplicates? Yes, this is also a violation. Employee number, no duplicate. Employee number is duplicated. Not null, it's okay, it's not null. So rest of the things are same. Okay, now we are going towards our second constraint, that is primary key constraint. So far, what did we saw? What did we see? We saw not null and we saw no duplicates. If we say some column is a primary key, it means that it is no duplicate and it is not null. It is automatically no duplicate and it is automatically not null. Clear, guys? So primary key joins the two things together. Okay, now let's look at the figure. This is the table department and it has department number, department name and location. I want to insert a new record here with the values 20. Okay, department number is the primary key. Values are here 20, 30. I want to insert a new record with department number 20, department name marketing, and location Dallas. Should I be allowed to insert a new record here when I say department number is primary key? Should this record be allowed to insert into this table? No, why not? Your answer is correct. We should not be allowed. Why not? Because 20, I'm trying to insert 20 here. This is department number is primary. Department number is primary key. Primary key means no duplicate. I'm trying to insert 20 again. It will be a duplication. So the first record, I should not be allowed. What about second record? Should I be allowed to insert the second record? Yani null value, null finance, New York. Can I insert a null value in primary key? No. Department number is primary key. I cannot insert a null value because primary key cannot be null, it cannot be duplicate. So I cannot insert the second record also. Okay, foreign key, alhamdulillah, we have already discussed foreign key. Okay. This is the, how do we mention the foreign key? We make a diagram like that. This diagram is, its name is referential integrity diagram. It mentions all the foreign keys. Okay, so foreign key references, how do we mention? We make a referential integrity diagram. Just look at it. For example, okay, let's first of all see the tables. This is the table employee. It contains first name, middle initial, last name, social security number, birth date, address, sex, salary, super security number, department number. Second table, department, department name, department number, manager social security number, manager start date. Third table, department location, that is department number, department location. Project, project name, project number, project location, department number. Works on is another table. It has employee social security number. So again, it is social security number. Project number, hours. And department, it has employee social security number, department name, sex, birth date, relationship. And you see some of the attributes which are underlined. Underlined means these are primary keys. In employee table, what is the primary key? Social security number. In department, what is the primary key? Department number. In department location, what is the primary key? Department number and department location together, this is the primary key. We call it composite primary key because only one of them, it's not possible to have the unique values. However, we can join two columns or three columns together to make a primary key. That is called composite primary key. It is perfectly fine. It is perfectly allowed. In this table, project number is primary key here. Works on is the primary key here. Employee social security number together with dependent name. This is the composite primary key. Okay. First of all, we say this social security number is a primary key here. Does this social security number exist in any other table? Yes, it exists here. So we will make it a foreign key here so that it is always connected to social security number here. Does this exist in any other table? Yes, it exists here. Employee social security number. So we also make this foreign key. So we link it here with this line. This is linked. Third, we have a super social security number. Again, this is the security, same security number. We must connect it with here. So this key, this attribute, foreign key of the same, some attribute in the same table. It is possible. You are seeing it for the first time. A key or an attribute in the same table, it can be referenced to another attributes. It can be super means manager social security number. This is perfectly fine. What about others? This department number, does this exist in any other department? Yes, it exists in this department. So you link it here. Here it was the primary key, and here it will be foreign key. Look at that. You call it D and O. Here you call it D number. Actually, it is the department number. Here you call it a different name. Okay. Just like I call you your name, for example, Faraz, or I call him Ibn and then his father name. The person is the same. If the person is same, then we definitely link it together. The title doesn't matter. Similarly, we are connecting this department number from here to department number here. This project number is connected to the project number here. Employee's social security number already connected here. And this department number is also here. And here is the primary key. Here it will be foreign key. Department number is also here. It's the foreign key here. So these all connections must be made. Let's practice it with the help of one example. It's time for the brilliant guys. I know you are all brilliant. but you have to speak then. If you are brilliant, you have to show it, prove it. Okay, we have two tables. The first table name is Q. This table, first table is department table. Second table, employees table. In the department table, we have department ID, department name, location. In the employee table, we have ID, name, job, manager, hire date, salary, commission, and department number. This department number, we already have it here. It is department ID or department number, same thing. So here it is the primary key. If it exists in any other table, the same thing, we make it foreign key there. So in this table, employees, this column is the foreign key. What does this mean? It means all the values here must be present in the parent table. If we try to enter value here, which is not available here, it's not possible. A foreign key, a foreign person, first of all, it must exist in its parent table. If it does not exist in the parent table, how can it exist here? Like Dr. Farrukh. How can Dr. Farrukh exist in Saudi Arabia when he does not exist in Pakistan? Funny, right? Isn't it funny? So, if Dr. Farrukh wants to exist in the foreign country, first of all, he must exist in his parent country. That's the same thing for the values. If you insert a value 10 here, it must be present here. 10 is here? Yes. Department number 10 is here. First of all, department number 10 should be here. Then is 10 allowed, next is 10 allowed, 30. Is there any department with department ID 30 here? Yes, it is allowed. This is the concept of foreign key. Okay, let me explain it with the help of the same. First of all, what is foreign key? If an attribute or field, if an attribute or field or column, it exists in the two tables or more than one table. It can be in the 3 tables, it can be in the 4 tables, perfectly fine. If that, like here, department ID or department number, we also have it department number here. One of the table is parent table for the department number. Department number is employee the parent table or departments the parent table. Of course, the departments is the parent table. So in the parent table, we have the column department ID. We also have the column department ID or department number in 2 tables. In the parent table, if this is the primary key, we make it foreign key in the other table. Okay, like I give you example. Let's talk about Dr. Farrukh. This is Pakistan. I was born there, so I am national to Pakistan. So I have my ID in Pakistan. When I come to Saudi Arabia, this is the table for Saudi Arabia, and I have my ID here. So this is Dr. Farrukh here. Should my record in Saudi Arabia be connected to my record in Pakistan? Of course. Of course, it is very, very important that my record in Saudi Arabia must be connected back to my record in my parent country. This is very necessary. That is what we do. We do the same thing in our relational model. We are studying in this chapter relational model. It means our data items, if they are repeated in more than one tables, we must connect them together. Okay, at one place, the data items will be primary key. This is the main table for it. And in the second table, we will make it foreign key. Like in Pakistan, Dr. Farrukh was national there, primary key. Dr. Farrukh in Saudi Arabia is foreigner here. Dr. Farrukh exists in Pakistan, Dr. Farrukh exists in KSA, Saudi Arabia. So how we will link him together? we will make him primary key in Pakistan, and we will make him foreign key because he's a foreigner here. So this is the concept of foreign key. Now answer me one question. If Dr. Farrukh exists here in Saudi Arabia, but he does not have any record in Pakistan, is it possible? Should we allow it? It's not possible. We must not allow this. So if Dr. Farrukh is here, first of all, he should exist in Pakistan. First of all, he should exist in the parent table. If a value is here, 10, we should allow 10 here only when 10 is available in the parent table. Next value, 30. We should accept 30 only if 30 is available in the parent table, because we said that this is a foreign key. We made it a foreign key. So all the values here, first of all, they must exist in the parent table. Okay, time for you to win stars. This is our scenario, which I explained to you. Now I want to insert two new records here. First, record number 1. I want to insert in this table the values 556, it means ID. Cricket, it means something, last name or job or whatever. The PU clerk, something is the job. Then he left some other items. The last, look at the last value. Here is salary 5,000 and department number 25. I want to insert this record where the department number here will be 25. Should I be allowed? I want to insert this first record in this table, employees. And the values here, 556 will go here, cricket will go here, PU clerk will go here, 25 will go here. Can I insert this record here? Okay. Ahmad Ali, Rayan, Abdur Rahman, they say no. Anybody who says yes? Okay, why can't I insert this record? Why I cannot insert 25 here? Yes, mashallah. If I want to insert 25 here, this department number is a foreign key. Look at its original parent table. Is 25 here? Yes, mashallah, Hasham, excellent. Excellent, Rayan, excellent. I want to insert 25 here. I can insert 25, this is a foreign key. I can insert 25 only if it is available in the parent table. It is not available, so I should not be allowed to insert 25 here. Excellent. Very good, guys. Example number 2. I want to insert now second record. 556, first record rejected, second record, and here is null. Can I insert this record here? Ahmad Ali says no. I want to insert null. So null means absent. Will you absent, find absent here? I cannot compare absent with something. So in foreign key, absent is allowed. I can insert null value here because it does not violate my checking. I will check 30. I will check 30. If I don't have a value here, what will I check with? I cannot check it with anything. So null value is allowed in foreign key. Remember this thing. It's written here also for you, and you should remember it. Okay, let's go further. Besides this constraints, there can be some other constraints. It depends upon the business you are doing. It depends upon the company for whom you are making database. Maybe you are making database for KU. Maybe you are making database for Ministry of Interior. Maybe you are making database for some other department. So they will tell you what other conditions they need and you will also implement those conditions as constraints. Now it is time for us to do some class exercise. Okay, our class exercise is, yeah, we are doing a class exercise now. Please, all of you, read with me. All of you, please consider the following. Whatever we have learned so far, we are going to practice it now. Consider the following relations for a database that keeps the track of student enrollment in courses and the books they adopted for each course. Yani the book they got from library or department or something. The first table is student. And what do we store in that table? Social security number, name, major, in your case it is IS or IT or CS, birth date. Second table, course. We store course number like CPIS 240 something. Course name, department. Third table, enroll. SSN, course number, quarter, you can think of it as semester. Your Faslul Awwal or Faslul Darasi Awwal, Faslul Darasi Sani or Faslul Saifi. These are your quarters. We don't have quarters, we have semesters here. Then your grade. Book adoption, another table. Course number, quarter, book ISBN number. Text, then this is your textbook basically. Book ISBN, book title, publisher and author. For this database, draw a relational schema diagram specifying the foreign keys for this schema. So you are required to make a figure like this. You will make tables like this, and then you will mention the primary keys and you will mention the foreign keys by drawing these arrow signs. Okay, this is the question. It's in class practice, so we will do it all together. First of all, tables are already given to you. This is the table, this is the table, this is the table, table, and table. We need to mention primary key. We know already it is underlined. Even if it is not underlined, wait, primary key, okay, we can say if it's not, even if it is not underlined, you can select primary key by yourself. What is the primary key here? Social security number. Course number is primary key for this table. Thank you, Ahmad Ali. For enrollment, the primary key is social security number plus. Originally, we cannot have it one. We have to have a composite primary key of 3 together. Okay, you will learn it later. By and by, inshallah, you will realize when to make composite primary key. Right now, this is not the time to learn it. Our time is to learn the foreign key references. For book adoption, primary key is course number and quarter. It's written here, primary key. Let me make it green, all the primary keys. For this table, the primary key is book ISBN. Okay, this is the primary key. Do we see the links between the tables? Answer is yes. That's why this question is here. That's why we are asked to make a relational schema. So how do these things link with each other? Enrollment. What do we see here? First of all, we have a social security number, and it should come from student's social security number, because here it is primary key. So in this table, this social security number will be a foreign key. This is the first thing. Foreign key, this social security number here, it has its reference from social security number in student table. So this is the name of the table and this is the name of the column. This is one foreign key that we make. Second, course number. We have a table with the name course and we have its foreign key, its primary key as course number. So this course number here must be linked with course number here, because here it is primary key. So we should make this as a foreign key. So we make a foreign key FK, course number here. It has its references in table course and column course number. So we write here course dot course number. Another format is we write it in bracket or we write it in with the dot. Okay, this is for you. For here Oracle, we write it with dot. So first is the name of the table and second is the name of the attribute. Similarly, in the third table, this course number, once again, it should be referred to, it should be referenced to this course number, yani make it a foreign key with its course number here. Okay, so we have a foreign key here. Second is book ISBN. Book ISBN, it should come from the book. Is there any table from the book? Yeah, we have it here. So book ISBN, it should come from here because you adopted a book. This is the table for book adoption. So it must have its references back to the original textbook. So we write here foreign key. Where is it? It's written here. Book ISBN, it has its references as from the table textbook, text, and the column name is book ISBN. Okay, you can think of something course number also, but it is not needed. This is extra, some student may make it, so it's not needed. We will see it next, inshallah. Next step. Step 1, find the table. Step 2, find primary keys and foreign keys. Step 3, make a relational schema like this. Step 4, link them together. Like I showed you in the previous picture here, we should link the primary keys to the foreign keys. So the direction of arrow should be from the foreign key towards the primary key. Arrow sign should be towards the primary key. This is our relational schema. This is our requirement that draw the relational schema diagram. This is our relational schema diagram. This was an example just to show you what do we need to do. We need to make a figure like that. So this is the output.